Before solving the problem involving the manipulation of fractions, let us look at two processes that have the potential to shorten our work. So we are about to manipulate fractions, but in the manipulation of fractions there are quite a few processes. Now we are going to take a look at two of them, and those two have the potential to shorten our work when we go to the manipulation of the entire fraction, the fraction in its entirety. The first one is to write a mixed number as an improper fraction. How do we do that? Well, we have a format that we're going to be using, but let us identify W as the whole number, D as the denominator, and N as the numerator. The mixed number will have the format, and we have the format right there. We'll take the denominator, multiply that by the whole number, and the numerator is added to the result. The denominator of the resulting improper fraction will be the original denominator. We don't have any difficulty with that. Let us see how this works with a real mixed number. So here is our real mixed number, and what does the format say? The format says that we should take the denominator and multiply by the whole number. So we're going to do just that. The denominator multiplied by the whole number, and of course it is making a lot of sense already. It is working in the way that it should, because you will see right here on your own that we need to add the numerator to that. So the numerator will then be added, and just by making use of the format, we also know that the next thing is that we need to divide by the original denominator. No problem. That may be simplified in a few seconds. Now, I am not one for rigidness or sticking slavishly to a format, but we're just putting a format here, or something that some student might be able to turn to if they desire, or if it is required in some way or the other. So it's just a matter of documentation, but of course we know that the process is very simple and straightforward. We are just giving a format here so that we have something to turn to if we want to make a reference to a particular process that might be used to convert a mixed number to an improper fraction. So let us complete the process. We have it right here, 4 times 2 plus 1. So 4 times 2 is 8, as we have right there, and then the 1 is added to it, and we have 9. The denominator is the same. So 4 2's 8 plus 1, 9, and we place that over the original denominator. Next, we will look at the quick and easy way to add fractions whose denominators do not have a common prime factor. So if fractions have denominators that do not have a common prime factor, we may shorten our work by just making use of this format. If you do not make use of the format and you just do it naturally, it's fine, but the result will be the same. So what we have here is just a way in which we can shorten the process in terms of time. So the result will be comprised of 3 products. Remember now that the denominators should not have any common prime factor. And if they do not have any common prime factor, then this is a very quick and simple way to add those fractions. 3 products. The first one will be the common denominator, which will be the product of the 2 denominators. So the common denominator will be the product of the 2 denominators, and that will happen if the 2 denominators do not have a common prime factor. Then The first product of the numerator is the leading diagonal. And that is what a leading diagonal looks like. So that's the leading diagonal. The product of the leading diagonal will be the first product of the numerator. And the second product in the numerator will be what we know as the subordinate diagonal. The other product of the numerator is the subordinate diagonal. And that's a very simple process. 3 products. The first one, product of the denominators. Second, leading diagonal. Third, subordinate diagonal. And those are the 3 products that are used or may be used in adding fractions very quickly when the denominators do not have a common prime factor. So let us see how that works. And you can see that happening very quick and simple. 5 and 4. They do not have, those are the 2 denominators. They do not have a common prime factor. So the denominator of the result will be the product of the 2 denominators. The first product in the numerator will be the leading diagonal 2 times 4. Then the second product of the numerator will be the subordinate diagonal 5 times 3, or we'll prefer to take the top 3 times 5, 5 times 3. Multiplication is commutative, so the order does not matter. As long as we are dealing with the subordinate diagonal, we will be correct. Then it's a matter of simplification. 2 4s 8. 5 3s 15. So we will have 23 there. But do not forget that we generally put the common denominator first. It's going to be just 5 4s 20. That is going to be 8. The next one, 15. When we add those together, the result is 23, as we mentioned before. So there we have the common denominator. We are always placing the denominator first, and then we will have your numerator. And it is as easy as that. Multiply the 2 denominators, that will be the common denominator. Leading diagonal, first product. Subordinate diagonal, second product, and we are through. Shortened versions of these processes will be used on the solution slides. So when we are doing the solution slides, we are not going to go through all of the processes or all of the steps in the processes. We are just describing the processes before, so you have an idea of what we are doing when we are going to actually solve the problem that is given to us by the CXC examiners. So let's go. There is our sophisticated arithmetic expression made up of quite a few fractions, and let us see what we will do with that. Now the first thing that we will do is shuffle it around a bit to cause it to be or to appear less cumbersome. So we are going to rearrange this in order that it might be less cumbersome. When a fraction is expressed in this manner, or any manner for that matter, the fraction bar separates dividend, which is the numerator, from the divisor, which is actually the denominator. So if you have a large fraction bar here, it means that the entire numerator is the dividend and this is the divisor. Therefore, all of this is being divided by 3, and we might rewrite this in that manner in such a way that it is easier to manipulate. And if not even easier to manipulate, it might be easier on your eyes in terms of how you will process the visual information. That is also important in mathematics, the way that an expression appears. So there we have the top, entire top, which is the dividend. We have the fraction bar that depicts division, and we have the denominator, which is the divisor. It means that the fraction bar may therefore be replaced by a division sign, because the fraction bar depicts division. It may be replaced by a division sign. And what do we know? That we still have some work to do on the expression, because if we leave the expression like this, it will imply that we are dividing 1 3/5 by 3 instead of the entire expression. So to show that we are actually dividing the entire expression by 3, we will have to enclose that in brackets. The entire expression must be divided by 3. Enclosing it in brackets is the appropriate way to demonstrate this mathematically. So we are going to demonstrate it mathematically, that the entire expression that we had as our large denominator is to be divided by 3. So all of the expression that comprised the original large numerator is enclosed in brackets. Dividing by a number is equivalent to multiplying by its reciprocal. We remember that from primary school, that when we are dividing by anything, whether it is a whole number or a fraction, that we are multiplying by its reciprocal, and that is shown right there. The problem is nicely expressed in terms of fractions only, and of course, since it is just in fractions only, we may just go ahead and manipulate those fractions. Let's go. Convert mixed numbers to improper fractions. We have those there. The first one was done on a previous slide. I hope that you remember, and if not, we can rewind to the beginning of the audiovisual where we actually did one of them. So one of them was done before, which is this one was already converted to an improper fraction. Let us do this one. I had no idea that the animation would have done it on the spot. So let us go at it again. Remember that we need to take the denominator, multiply that by the whole number, and add the numerator. I remember that. And then this is what we will have. The product of the denominator and the whole number. We add the numerator to that, and of course we know what the denominator will be, that it will be the original denominator. And what do we have there? 5 ones, 5 plus 3. So that will give us, I hope that the computer does it the right way on this occasion, 8. So it will be 5 times 1, 5, plus 3, 8. And that will be 8 over 5. And we'll go into it also, if you can remember, that what we have here is the subtraction. Well, it's not addition on this occasion, but we are subtracting one fraction from the other, and those fractions have denominators that do not have a common prime factor. So we may go straight ahead and manipulate it by first multiplying the two denominators. So add two fractions whose denominators do not have a common prime factor. So we multiply the two denominators first, then leading diagonal, 5 times 9 goes there, subordinate diagonal. Wonder if we are going to put the 4 before the 8. Let's see. It doesn't matter because multiplication is commutative. Yes, we place the 4. first. But it doesn't matter because multiplication is commutative. The order in which we multiply numbers does not affect the result. And we take all of that, and do not forget that we have our 1/3, and we will also ensure that we maintain that. Of course, the next thing that you imagine that we will do is the simplification of the resulting fraction. And we have a tendency to do the denominator first. So let's go. 4 5s 20. 9 5s, oh, we have to put the negative sign there, the subtraction sign. Then 9 5s, 45. Then 4 8s, 32. Do not forget that we are still dividing by 3, which is multiplying by 1/3. So we have to maintain that. Your denominator is 20. Anything else? Yes. We're going to say 45 minus 32. And, of course, do not forget that we are going to continue with our multiplication by 1/3. That will be shown there. And I don't think that the fraction may be further simplified, so our result will no doubt be 13/60. So multiply two fractions by multiplying their numerators, then multiplying their denominators. We are multiplying two fractions. How do we do that? Multiply the numerators and multiply the denominators. So we have 13 times 1 is 13, and 20 times 3 is 60. So that will be 13/60, and that will be our final answer. So I hope that you enjoyed this manipulation of fractions with its beautiful and interesting processes, and that when you have problems to manipulate fractions, you will find them to be very enjoyable to the extent that you will never get another one wrong. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.